Okay, guys, so you've survived the vocabulary piece of the tutorial, and so now we can actually talk about the common data model. I actually think this part of the tutorial is a little bit easier than the vocabulary piece, so hopefully we can relax a little bit now. So what we talked about all morning all had to do with standardizing terminology. So all our data sets use different codes. ICD-9, ICD-10, SNOMED, maybe MEDRA, and our goal in Odyssey is to standardize those so then when we do queries across our databases, we can talk about atrial fibrillation in the same way. When we talk about the common data model, it's the same idea, but all our data sets have different structure. And now we want it to have the same structure. So instead of writing 5 different queries for 5 different data sets, I can write one query and run it on 5 different data sets. And that's the goal here. So now we're talking about standardizing how our data looks and how it's structured. We've already looked at this earlier today, and these are the tables that are in the OMOP Common Data Model. Actually, today, you guys are lucky. You are the first ones to see the official release of version 6. So as of this morning, CDM version 6 was released. Claire later today is going to talk a little bit about what that means and also talk a little bit about the processing that we go through as a community to make upgrades as we learn how to improve the Common Data Model. But what's important before we dig into the tables is to know that there's key areas or key domains that you should be thinking about and grouping the tables in. So probably the domain that you think most about when you probably signed up for this class is clinical data. So in the blue on the far side, these are all the tables that store information that happens to patients. So you'll hear over and over again today that the Common Data Model is a patient-centric model, and all these tables are containing information that happens to those patients. So what were the drugs that the patients were exposed to? What conditions did they get diagnosed with? What measurements were taken on them? So I really consider that those blue tables are really the core of the CDM and what you're going to be doing the majority of your analysis on. In the red at the top, there's standardized health system data. So we do maintain some information about location. So maybe if you're lucky in your data, you know the addresses of your patients. Maybe you know the address of the physicians. You can store that in there. There's also information about care sites. So if you know your hospital names and you know where they're located, or maybe you know something about the provider other than their NPI number. Maybe you know their name and their gender and where they're located. These are the tables you'd store that information. And in this case, one provider may have multiple patients. And so we want to deduplicate that. We don't need to store Dr. Reich 100 times. There's also some standardized derived element tables. So these tables, we actually take the data that we've populated in the CDM and then we will derive some information. Later in this presentation, I'll talk a little bit about the drug era specifically and how that works and how we're deriving information from drug exposures to create the drug era table. Additionally, within these derived tables, we have something called the results schema. So if you're storing information in a CDM, you probably want to create some cohorts. So maybe you want to create a lymphoma cohort. And once you find those patients, you want to store them somewhere. We have standardized tables for you to do that and store those patient identifiers. And as well, give it a definition so that the next person who comes along can actually figure out what you were doing. There's also standardized health economic data. That's that green section on the bottom. So if you're interested in doing economics, understanding the cost of care for patients, we have standardized tables for maintaining that data as well. At the top here, we have standardized metadata. So this is data about data. So we have the CDM source table. This table will actually tell us a little bit information about the CDM that you're currently looking at. So on what data was it run on, when was it run, who ran it, what vocabulary did it use, so just some high-level information so you know what you're looking at. Maybe you're looking at the outdated version of the CDM, and the CDM source table might help you figure that out. Recently, we've been getting more into metadata about the data. So we're exploring how can we do a better job of educating users of the database about what's in the data. So if we've learned that death data after 2013 is no longer good in this database, somebody who has a lot of experience with the data might just know that, but a new analyst may never know that until they run across it. We are planning to start to get very good at using the metadata to teach people about what we've already learned. And that's where we'd store it in a standardized way. And what's great about that is if we have standardization, we can then use that standardized data and display it to the user, maybe in Athena when they're creating a cohort and trying to educate, hey, did you know death data is no longer good? Maybe you want to reconsider how you're constructing this cohort. And then finally, the last domain is the standardized vocabulary. So even though we talked about the vocabulary and it's its own entity, when you process a CDM, you're processing it on a version of the vocabulary. And you want to keep that version of the vocabulary with the CDM. Because as Dima and Christian talked about, is we're constantly improving the vocabulary. So if you don't keep them together and somebody is using a more up-to-date version of the vocabulary, they may be a little bit out of sync of how the data is looking. So for example, if a concept moved domains, let's say a concept was a condition and now is a procedure. I don't know why that would happen, but let's say it happened. The vocabulary is telling you where in the CDM to go look for that concept. If the vocabulary is changed, you now no longer know where it is. So we always bundle the vocabulary with the CDM. So those are the key domains, and we're going to go into the tables in a little bit more detail. Don't worry, we're not going to go through everything. So there's a lot of extra stuff that not everybody needs. Some key principles you want to think about when you're working with the CDM. We've already talked about it's patient-centric. This is core to how we're looking at and thinking about the data. So it's essentially an individual is generating information, and we're storing that information about an individual. This is not summary-level data. We've already talked about the vocabulary and the data model are blended and why that's important. You need to keep them together in order to know where to look for things. And that's because we have domain-oriented concepts. The vocabulary is teaching us or telling us when we're building the CDM where information needs to go. So it's easy to think, I have an ICD-9 code, that's a diagnosis code. But there are some ICD-9s that are actually procedures. And the vocabulary will teach us, no, this is not a diagnosis code. Put this in the procedure occurrence bucket. So that's that whole domain-oriented. And again, that's why keeping that vocabulary with your CDM is very important. The CDM can accommodate data from various sources. So a lot of people here might be thinking about data in terms of claims data or EMR data, but we've had survey data within the CDM and various other data sources. We have yet to come across a data source that's patient-centric that we can't shove into the common data model. And if you find that's the case, we want to talk about it and learn about it and figure out what we need to do to fix to get everybody's data source within here. The CDM also preserves data provenance, so this is really important. A lot of people, when they're used to working with their native data or their raw data, they're very concerned of losing what was in that raw data. Especially a lot of people are used to working with NDCs and used to working with ICDs. When we convert it, we're still bringing across that information. So even though we're standardizing things, you can still look at the ICD-9 codes that came across. You can still know where did that data actually come from in your raw data. So if you needed to kind of revert back and think, well, where was this coming from, you can actually figure that out within the CDM. You don't need to go back to your raw data to figure it out. We've talked a little bit about that it's extendable and evolving, so there are working groups. Claire, again, is going to talk a little bit about this. So if you see something that doesn't look right, we fix it. We just make it better. And because we're a community, we're always bringing in people with different levels of expertise so we can fix things. So for example, recently we created a table called specimen because we had some oncology folks who said, look, we need to store and understand specimen samples for our patients, and the current structure just doesn't give us the ability to do that. And so the experts in specimen data got together and said, what do we need to track? And created a table, and then that got added into the CDM. So as we bring people in, they teach us about where we need to get better. And it's database platform independent. So it doesn't matter if you have SQL Server or Oracle or Postgres. It doesn't care. The CDM can work in all of your database platforms. Okay, so just like that we have our standardized terminology and we have standardized tables, within the tables we try to follow a column named like pattern. So no matter what table you're in, we're going to refer to things in a similar fashion. So again, it's a patient-centric model. In almost every table, there is a person ID. It's always called person ID. This is also going to be a numeric column. We've talked earlier about, just like with concept IDs, numeric numbers are easier to work with in databases. You might have an alphanumeric patient identifier in your raw database. When you do the conversion, we would just reassign it an alphanumeric code. But we maintain provenance, so you can always backtrack and look what was the original code in the person table. But person ID is almost in all tables. Every table also has an identifier. So, for example, the condition occurrence table has a condition occurrence ID. And what that is for every row that gets written to that table, it gets an identifier. A lot of times, the identifiers are not really used for much, except when you're linking tables together. So a condition occurrence can get associated with a visit, and you'll do that through that visit ID. Otherwise, the order or the number it gets assigned is not really important. It's just a way to identify a single row in a table. And we've talked all morning about standardized concepts. So in the tables, anytime we've taken raw data and converted to a standardized concept, it then gets a concept ID. So for example, in the condition occurrence table, it's condition concept ID. So when you see that you know that that's using standardized terminology. And that's also what you should be running analysis on, looking if you're going to try to identify patients with lymphoma, that's how you would do it on that field. So in the example in the table, we've been talking all morning about atrial fibrillation, and that's the kind of column it would be stored in. There's also, like I said, with provenance, we're storing information about what was the original code that got brought over. We actually will translate them to concept IDs when we can. And we store a type, which tells us a little bit about where it came from. So the source value is exactly what it sounds. So if you have an ICD-9, you just send it directly over to the CDM as it was. So I'm sure some of you are familiar that sometimes the ICD-9 has a decimal and sometimes it doesn't. Just send it over the way it was in the CDM. You don't need to fix it or polish it up before you send it over. That also helps for troubleshooting if you're trying to figure out, is there a problem in your ETL? What was the exact data that you had? You could probably get back to the raw data and figure out, do you have a bug? Now, there are source concept IDs. We have realized that in some cases, our standard concept IDs don't always help you get to the answer you need. And some people are going to still do analysis on ICD-9 codes. What we do is, if we have a concept for your raw code, like we've been playing around with all day, we have ICD-9 codes that have their own concept ID, we will also assign that ID. So if you want to go look for ICD-9s, you don't have to look for that string of 427.31. You can then search for a concept ID, which will make for a faster query for you. Again, we try to always suggest when you're doing analysis to do it on standardized terminology, but we recognize there are situations sometimes where you need to use that some more granular information to help you tease out things a little bit better. And finally, the type helps with provenance in that it will tell you a little bit about where the data came from. So for example, this condition concept type says, oh, this was an inpatient header record, and it was from the primary position. So I do a lot of ETL builds. I use this information a lot to help me troubleshoot. Did I get all my records over into the CDM? Sometimes people use these types fields because they only want primary position diagnosis, or they want certain types of diagnosis. This will help maintain that information along the way. So just like we're standardizing tables, we have standard ways we name our columns. And so you'll see these throughout all the CDM tables. Okay, so there was a little homework. And what we're doing a little bit differently this year with this tutorial is we recognize that everybody comes to this tutorial with different levels of experience with data. Some people have only worked with medical records. Some people have only worked with claims. Maybe some people have only worked with survey data. And while the data is similar, it's still different. And so we found in these tutorials that people sometimes struggle when they're thinking in their head one thing, but we're kind of the examples or something else. So what we want to do is, Lauren is a real patient. We just stole this off the internet from endometriosis.uk. And she talks about her patient journey. And there's a lot of great patient information in her story that could be stored in a CDM. So we're essentially just taking her data and translating it into something that could get ETL'd. And while we work through the CDM tables, I'm going to use her information to shove into the CDM tables so you can kind of get an understanding of how an ETL builder will actually get things into these tables. So we'll walk through her information to see where it gets into the CDM, and we'll also talk a little bit about how some of this information might be generated. But what I want to do, just to make sure that we are all on the same page, I'm actually going to just read it out loud to you guys so we're remembering what happened to Lauren. And I'm going to just build out some of the things that happened to Lauren on this PowerPoint slide. I know it might be hard, but on the bottom here, I'm trying to illustrate her timeline. And so it's a broken timeline where I have data that was out a few years ago, and then I have data out a couple weeks ago, and then I have data out a few days ago. Now, I'm just extrapolating for her story. Maybe you might have taken away something slightly different from this, but it's just so that we have something to talk about today. So I'm going to just read her story out loud. So Lauren says, I've been experiencing endometriosis pains for 3 years, but was not officially diagnosed with endometriosis. About 3 years ago, I noticed my periods, which had been painful, were getting increasingly more painful. I started to become aware of a sharp jabbing pain right by my colon and feeling tender and bloated around my tailbone and lower pelvis area. My periods had become so painful I was missing 1 to 2 days of work a month. Painkillers sometimes dulled the pain, but usually they didn't do much. I had been in to see my GP about possibly having a cyst because I felt a lump in my pelvis below my hip bone. My GP wasn't convinced, and she said she couldn't feel anything on a pelvic exam. I finally convinced her to let me get an ultrasound, just to make sure. The ultrasound showed a 4x5 cyst on my left ovary. My GP scheduled me for a scan in 4 weeks' time. However, before I had my scan, I awoke one morning in severe pain. My husband called 999, but despite the obvious pain I was in, the medic still seemed unconvinced. I was eventually taken to hospital, where I developed a very high fever and became very bloated. However, I still waited for 3 days before eventually being given a scan, which showed an alarming amount of fluid in my abdomen. I was quickly rushed into surgery. Post-surgery, I was told that I did have endometriosis and that an endometrioma had ruptured in my left ovary and had attracted a fluid to it. This fluid had become infected, and that was causing my high fever and pain. So just her story online, that at least gives us something to think about in terms of a patient to get into a CDM. So this is just one patient's record. Okay, so before we think about how to get it into the CDM, let's think about where this data might come from. So admittedly, most of my experience with patient-level data is from the claims world. So there's a little bias in these slides of like, that's how I think about data. Mui, for example, thinks about data in terms of medical records a lot. So her perspective on data often is a little bit different than mine. So hopefully this resonates with some of you. But when I think of Lauren's data, I'm thinking of getting it from a claim. And so claims are usually forms that are filled out that have information about what were the diagnoses that the doctor gave, what were the procedures that the doctor performed that they're looking to get paid for, and what was the dates that things happened, or how long was the patient in the hospital. So it's just some high-level information. This data is, forms like this are what populate a lot of claims level data, and a lot of researchers use this type of data. Lauren could have also been given a prescription, and so prescriptions also contain a lot of information about who it was prescribed to, the dates, what was the prescription, how often to take the prescription, was she given any refills? And there could be doctor's notes too. So for example, if you've ever had to go into surgery or get a biopsy, a lot of times the surgeon or radiologist will just send back a report to the doctor making a statement about what they thought they saw or what they think is happening. So this is another way that data could come across. And there's a whole lots of other ways. So for example, she said she had a fever. In some hospitals, they have something to take a patient's temperature, and sometimes that automatically feeds the medical record. Just different ways to get the information in. So first table, and probably one of the most important tables in the CDM we need to know about, is the person table. And so this is for every person in your CDM, there is one record for a person in this table that talks about who that person is. So for example, it's going to talk about and standardize what their gender is, year of birth, maybe if you're lucky, month and day of birth, maybe if you're really lucky, the date time of birth. We're going to standardize your race, your ethnicity, and then if we know something about your location, your provider and care site, for example, if you're in Europe, you have one GP, and you may have that one GP cradle to grave. So in this case, it would make sense for a patient to be assigned to a provider. If you're in the US, you probably see lots of doctors in a given set of times. You might not be assigned to a specific provider. And then just like I said, even though you're doing a lot of standardization here, you're still keeping all the source values. So if you, for some reason, need to disentangle what might have been going on in race and see if the mapping was done correctly, you could still do that. Again, it's only one record per person, so there's no history information here. So a lot of times patients move, so they might have multiple addresses. Right now, what we do is we're only storing one, and when the person creating the CDM, they'll determine what is the most appropriate way to choose that location. A lot of times people just choose the last location. In terms of race or gender, you might just choose the race or gender that happens the most often. Because even if a patient always identifies as female, there might be an administrative error just randomly somewhere within their record. And so how do you think about handling that? Year of birth is required. So we really can't do any type of analysis if we don't know when a patient was born. So we require that patients have years of birth, which means sometimes when you get your patient level data, if they don't have a year of birth or if they were born in 2099, you probably are not going to put them in your CDM. But that's also because what analytic value does that person have if you don't know how old they are or if they're born in the far, far future? And then I also highlighted there's foreign key relationships to like what could their location be, their provider or care site. So in terms of Lauren, let's make up some information for her. So this is just a subset of the columns to give you a sense of what this could look like. But Lauren could have a person identifier from the raw data. And what I can see is that her ID that the CDM has given her is actually the same ID that was in the raw data. So it wasn't an alphanumeric code, so we just took her ID that the raw data had. If maybe it was A12345 maybe we just truncate the A off so that we can still identify her with a number. But in this case, the data source was nice to us and kept it in a numeric format. So this data source also listed Lauren as being F, or some data sources you might be 2 or 0. So what we've done is we then standardize the fact that she's female to 8532. That way you don't have to worry about if it's 0, 2, or F, or female. She has a year of birth. We don't know her month of birth. We don't know her day of birth. That's all fine. And she has listed herself as being white, which we can also standardize that. Just like male and female, the races can come across in a lot of different funky ways. So this case, white was just listed as W. Any questions on that? It's pretty simple, right? Okay, so now that we have people information, the next thing that's really important to understand about the people is their observable time. So we want to know what spans of time do we actually have capture of data for these people. Now, in claims world, this is actually very easy. Patients are enrolled in a health insurance for a certain amount of time. And the health insurance will actually say month by month, was that patient, month by month, year by year, was that patient enrolled? And so what you can actually do is stitch them all together to say, Lauren was enrolled from 2000 to 2018. And so you just know that you pretty much have her data during those times. And one person can have multiple observation periods. So for example, I'm sure many people in this room, you've had one health insurance, you've left that health insurance, and then you've gone back to that health insurance. So for example, if you had Aetna and then went to Blue Cross and then went back to Aetna, and we have Aetna data, I would have 2 spans of time for that Aetna data. And this observation period is really important for all our analytical methods because we want to understand when are we actually going to see data from you. And the thinking behind that is if we're not going to actually see data from you, it's not that you're this healthy person that's not putting anything into the CDM. It's just that you don't actually contribute any data during this time, and those are completely different things. Being very, very healthy and not visiting a healthcare provider versus you're just never going to see data for this person. And so while I said claims data is really easy, this can be tricky for other data sources, and people need to talk about this. So for example, in EMR data, you may not be 100% sure when is the actual capture of data for your patients. But there's lots of great discussions online. There's lots of people who want to talk about this. So if you're not sure for your data set, all you need to do is just raise it on the forums, and somebody probably has already thought about this, and you can just leverage their thinking. So for Lauren, her time period is really this area below. So these were times when we were getting information about Lauren. And so I've just made something up for her. She has 2 observation periods. You can see that she's got her little identifier here, and she has observation period 1 and 2, and 1 went from 2000 to 2010, and then she came back from 2012 to 2013. Okay, so let's talk about visit occurrence. So visit occurrence describes encounters within the data. So when patients are actually meeting with some kind of healthcare provider, and it will describe the spans of time. So if you go to the hospital and you're there for 5 days, this is the table that's going to describe you've had an inpatient visit and you were there for 5 days. When did it start and when did it end? So same things, we have our person identifier, it has a start date, an end date, also it tells us the type, so this is going to tell us a little bit about where that visit information came from, provider, care site, and then all our providence type values. It's important to note though, in OMOP Common Data Model, we really only have a handful of types of visits that we consider. It's either going to be emergency room, inpatient, inpatient/emergency room, because sometimes you can't tell when they left the emergency room to an inpatient stay, outpatient, and long-term care. These are the only types of visits that we currently support. So sometimes you need to think a little bit about what's the most appropriate visit type for the data that I'm seeing come across. So Lauren specifically talked about 2 different types of visits. She had a GP visit, which I would discuss as an outpatient visit, and she made a hospital visit. So she stayed overnight in a hospital. So here's her 2 visits. Again, you see her IDs. An outpatient visit is usually, if the data looks fine, is going to be 1 day and not more than that. And then an outpatient visit will be 1 or more days. And again, the definition of what type of visit it is standardized to a code because, again, each of our data sets are going to tell you it's an inpatient versus an ER in different ways. And so we can just standardize this for the analyst. Any questions? You guys look really sleepy right now.
Quick question. In terms of the facility type versus setting, right? So you have inpatient, outpatient, but someone could have an outpatient visit in a hospital for surgery, or could also have an outpatient visit to a physician office, right? So is that coming from the provider table data?
Yeah, so that's a really, really good question. So let me answer it with an example that I think about when I think about visits. So for example, one thing we can see that happens in data is that a woman goes to have a baby in a hospital, usually, but the OB isn't part of the hospital. They are actually a physician from somewhere else. So sometimes they will submit a physician-type claim. It will come across and look like an outpatient visit. And so what you actually will see in your data is you'll have woman goes in the hospital and she's there for 3 days or whatever it is now. And in the middle of it, there's an outpatient visit. So it doesn't make sense that the woman left and came back to deliver the baby. So sometimes in the ETL build, as we learn kind of these funky things about the data, we will actually reclassify some of the visits. Again, we maintain data provenance so we can tell the user this was outpatient, but I'm telling you now it's associated with this inpatient visit. But I don't know if I've answered your question.
So I think what you're making a point is between a CPT versus an ICD-9 procedure, the CMS 1500 form or a UB92, right? I think sometimes one thing is where the site is, but what's the facility? And sometimes for procedure-related research, I think that nuance becomes important. But just kind of
yeah, we actually. So this is what it is today, and we're gonna roll out a real hierarchy, so you can have these details underneath. Because for the reason that exactly you said, there are these subtleties, and you can have a surgery in a hospital, with a real operating room, and then you can have just a normal office, and you can have anything in between, and these subtleties we have, and we should be able to represent them. So today there are 5 visit concepts, and they're going to be like whatever, 150. The 5s are still going to be the ones that are on the top, and underneath you're going to have all the detail you need.
Yes, thank you. That was a better reply than mine. Yes, there's a visit detail table that I'm actually not going to talk about today, but this is the higher level version. Any other questions from my sleepy audience? That's a great question. So the question is, are we operating under the assumption that we're getting a patient identifier from our source? And so when we're doing the ETL builds, we have to have some way to distinguish patient from patient. Sometimes we can't. And depending on your data source, you may then choose to eliminate some patients if they're too intertangled. Otherwise, a lot of times in the build, you'll generate a way to think about, like, I know I can identify a patient if I do X, Y, and Z. So you might need to do 5 steps in the raw data, figure it out. But then you can just build that processing, saying, when you go to the CDM, do this work to figure out who's A, B, C, or 1, 2, 3, 4. Does that answer? Yeah. Because depends on the situation. So I have a data set where I have a Medicare data set where it's a known problem that sometimes Medicare IDs do get reused. Very small percentage. It's like 0.001% of the data. And it's easy to identify them. It'll be like a woman here until 2010, then nothing, and then a man for the rest of the record. But you can't like disentangle who is who. So in those cases, I've made the decision in my CDMs to just drop them, because otherwise you're not going to know, was it a man, was a woman, when were they born. But in other cases, for other data sources, it may make sense to keep that information. And I don't know if some of the other faculty do you have any good examples where you might keep somebody?
But what was the question? That if a person doesn't come with a patient ID? Okay, well, when, I guess I've seen a data asset that where a person doesn't come with a patient ID, because how are you gonna relate all the other transactions to that patient?
Mm-hmm.
Has to have a unique ID, right? Unless it's one big gigantic fat file that says patient one went to the doctor, same patient, the next record. The patient went to the hospital in the next record. But then at that point in time, you have to work with your business people to say, okay, how do I uniquely identify a person? And then create your own ID from that. Because, or else, how am I supposed to make, I mean, OMOP is a relational database. Now I'm talking techie terms.
But there could be some cross-sectional surveys there. The concept, so I think for claims and EMR and other things it makes sense, but there could be a cross-sectional survey where it is a little bit of a flat file. So
Right. Yeah, and I've seen surveys like that, but even with surveys, a lot of them, there's a unique ID in there somewhere, like a survey number or something that you can use, right? And ETL isn't as simple as it seems like that. We're just gonna take it here, and it prints it perfectly here. So if anyone's done it, it's not easy, it's not simple, okay? And you always have to have someone who has the business knowledge, not just technical knowledge. The business knowledge to tell me that, oh, here's how I uniquely identify a person, because I don't seem to have a unique identifier, because all I got are the names, right? Or all I got is their names and their birthdays and their gender. Maybe that's your unique identifier, I don't know. If someone else has to tell you that, I have to say it's not that common to have a data asset that doesn't have a name in it. I'm not saying it doesn't happen, but it's not that common. Because for most people, unless you're working with file, even there, I have some way of doing it, because when I bill somebody, I have to have a way, right? Granted, my name is very unique, but I know a lot of people's names are not that unique. So.
Oh, there's lots of questions. I think, oh, sorry.
I know for one patient, usually you get regular occurrence ID 1, 2. But your system, your whole system, wants to figure out how many visits in the certain period, how we can easily to get the number.
So the question is, when the visit data is going into the visit occurrence table, it's going to get a unique identifier, 1, 2, 3, 4, 5, just to whatever, a million. And then if you want to find for a given period how many visits a patient had.
Oh no, like how many patients in the hospital in a certain period.
Yeah, so actually using that table, it's very easy. Let me go back to it actually. So what I'd be able to do is say, tell me all the visits that started, and maybe you want them to end before that time period, but started during that time period, and have a specific type of inpatient. And that will send you back all the people who went to the hospital during that time.
My question is that, for the column visiting occurrence ID, is kind of unique ID across the whole table, or because the unique ID on the patient level?
It's a unique ID per row. So every single person/visit has a unique ID. So like in Lauren's case, Lauren had 2 visits, 1 and 2, for her. So she has 2 records in the visit occurrence table.
But there's not another visit occurrence ID of the number 2 in it.
Yeah, so 2 is only for Lauren when she went to the inpatient. There's no 2 again. It's a unique identifier. Yeah, so you just, as like for example, when my builder's running, it's just auto numbering them. And it should be like a primary key, so it shouldn't even allow you to.
Yes.
Yeah.
Technical terms, yes.
Yes. Good question.
Is there a way to, with the sort of condition occurrence, to disaggregate where you're getting that information? So I think obviously this is a U.S. perspective, but in the U.S., the problem list is substantially more suspect than other sources for conditions. So how do you deal with that?
You're getting ahead of me. But yes, I'll talk about that. But it's the type field will tell you exactly what diagnosis code it came from. 1 through, I think we have up to 25, depending on what your data set gives you. But yeah.
What's your recommendation for addressing the biggest units in Apple, like critical care units?
Oh, different care sites?
Yeah, I mean, like, patient goes to the critical care unit, for instance, during the inpatient visit.
Oh.
So how can you address those?
That's
That's a really good question. I don't know if we're gonna go over that, but we have a table called visit detail to handle that. So say you're in a hospital and you move between units, we now have this visit detail table that you can say, oh, at this time, this person was in the ICU, then they moved to the CCU, then they moved to the step down, and it'll all have the one visit occurrence ID, but then each one will have their own visit detail ID, all with the same visit.
So what Claire is saying, I'll just repeat it, is that we're not talking about it today, but there is a visit detail table which would give you that kind of more granular level of a visit. So one visit can have one-to-many visit detail records, and one visit detail can only have one visit occurrence record. But that would give you the information.
So an additional one along those lines. So I'm looking at vision occurrence, you have a home care provider, right?
Mm-hmm.
You can have several different types of roles.
Yes.
Provider role, and if you do, which provider is responsible?
Yes, these are great. So the question is, a lot of times during a visit, so it's easy to think about this in terms of an inpatient visit, you're probably going to see more than one provider if you stay there for 10 days, right? So yes, right, this was one of the limitations of the visit occurrence table. So before we had the visit detail table, we had to just pick one. And there's no good way to pick it. Sometimes the data will say, well, this was the main provider, but usually not. And especially from claims, it does not tell you. It just lists them all out. So we would just select one, but you're losing information. And then that's why we decided we really need this visit detail information. So yeah, it sounds like everybody's very excited about that. So,
Along the same lines, does the platform provide the attribution algorithms? Say we have 100 claims for a person, but we want to identify which provider is the PCP for the person. You alluded to that earlier on. The multiple providers can see a person doing this.
So the question is, if you know who the patient's PCP, how can you attribute that to the patient? And actually, if you did know the patient's PCP, in the person table, you can actually list their provider there as their primary care provider.
My question is, if I don't know the person's PCP, can I infer who the PCP is out of a list of 20 providers?
So the question is, if you don't know the person's PCP, can you infer it and then use that information given the providers? So in your ETL build, if you determine I have a good algorithm for figuring this out, then build it into your ETL, and then you can apply that to your patient ID. So for example, for example, in some of our data sets, we've learned an algorithm for figuring out pregnancy episodes. And so it's not something that the data vendor told us or provides any information to do, but using the claims, we were able to figure it out. And so once we have that algorithm, the best way to implement it is, instead of letting each individual analyst have to figure it out, we just build it into the CDM, and then you can just look it up in the CDM. So.
And then we have something similar. So in one of our big systems, we know who their health plan was, and then we know who their doctors they went to. So we have an algorithm in there that says we look at them and we look at which doctor did they go to the most, right? And put a weight on them. Was it the weighting system on that? And then determine from there whether or not we can infer that that person went their primary care physician. So, but it's all, a lot of this is in your business logic and in your ETL. So the whole purpose here is so that the analytics and the analysts can do their job without having to do this guessing game.
Yeah, and usually the people doing ETL know a lot about the data, maybe more than an individual analyst may know. So for example, like Mui has more information about her providers. The data I get about providers is nothing. It's like an NPI masked encrypted code. That's all I know. So we don't spend a lot of effort to figure out which ID you are because we don't even know their specialty half the time. So I'm gonna keep going because we got like 30 minutes to get through a bit more slides. So hopefully I'll answer some of your questions along the way, like where does the diagnosis come from? So next table we're gonna talk about is condition occurrence table. And this is a table where we're gonna store when we believe that there is a presence of a disease or a medical condition, or a sign or a symptom. And again, we have our patient identifier. The condition occurrence ID, again, this is a unique identifier for that table, 1 to whatever. We will standardize the disease state to a standard concept ID. We can put a start and end date on that. The type field is going to tell us where it came from. So if it's diagnosis 25 from an inpatient record, that's where we would describe like that's where it came from. That's the condition type is also a great troubleshooting when you're trying to go back to your raw data and to see like where the records came from. If you're lucky and your data gives you a stop reason for a condition, you can record that. If there was a specific provider associated with that condition, if that condition diagnosis is associated with a specific visit, that's where you can attribute it to that. So for a given inpatient visit, I can tell you all the conditions that showed up during that visit. And again, some provenance information, like what was the exact code that came across, if it's an ICD-9, did it have a dot or not, and then map it to a concept ID. So Lauren had a lot of conditions in her story, unfortunately, and I'm just highlighting those here. And so we can just take, the main point of the story was her endometriosis, so I'm just gonna take that one for an example. So here again, we have Lauren's ID. We've mapped, she had an ICD-9 diagnosis code of 617.1. In this data set, they've eliminated the dots, so I've just brought it over as is. I then use logic to query the vocabulary and say, I have an ICD-9, and now I want to get the standard concept. In this case, it's endometriosis. Her record came across with a date of when that diagnosis happened. In this case, it was an inpatient detail claim that came from the primary diagnosis in this case. This came off of Lauren's visit 2, so that was her inpatient visit. And because this was an ICD-9, that ICD-9 code also has a concept ID. So I'm gonna take that ICD-9 and say, what is your exact OMOP identifier in the vocabulary? Because really, if you want to do your ICD-9 analysis, it's better to do it using a code than searching strings, because this will be a string. Any questions on? Go ahead.
End up hopefully being a yes/no question. So most of our in-hospital patients have multiple conditions, multiple issues, all going on at once. Do you do a separate one of these for each condition?
Yeah. So this table can get very big. Yeah, like billions.
And then you link them?
With the person identifier. So it's easy. If you set your database up appropriately, it's actually easy to then like say, if you know the group of people you're interested in, say for these people, tell me their conditions. That's actually a pretty fast query. But yeah, these tables can get into the billions and billions of records. Question? Yeah, yeah.
Do you have recommendations on those as well?
I am not the best person.
They're all in the,
Yeah, they're.
if you're setting up this, a CDM, there are indexes available for
Yes.
6 different SQL data.
So Claire was saying that in the Odyssey GitHub for the CDM, all the code to set up the CDM is provided there, which includes indexes. But as any DBA in the room might tell you, there's a little bit more to it than that. That's the stuff I couldn't tell you, like what's the most appropriate way to set up a SQL server. That's a DBA might be a little bit better to tell you that.
This one is how we can put the past medical history in this table. For example, patient had a heart stroke 1 month ago. If a patient had
Yes.
a heart stroke again, how we can deal with this situation.
So the question is, what do you do with patient history? So a historical, like the patient mentioned, I had a heart attack in the past. So I think a lot of data sets handle this in slightly different ways. So you have to think about it for your data sets. In my experience, a lot of what we've done is because we don't know when things happen, when a patient's just making a claim of, there was a survey and they said something like, I had cancer before, you can just, there's another table we're gonna learn about, the observation table. So sometimes when we're not really sure, like, is this information we want somebody to be using and doing analysis on, we'll shove it into the observation table. With that said, there are diagnosis codes that say patient history of blah, and that happened on a certain day and a physician made that. That will still go into the condition occurrence. But like survey data, sometimes we just keep it to the side because we're not really sure when the drug exposure happened, when the patient actually had that condition. But there's lots of good conversation on the forum about this because lots of people think about it in different ways. Okay, last question and I'm going on.
So FDA is very interested in adverse events of drugs, right?
Yep.
So giving a condition, do we know how the condition is really the adverse event of the drug, or is really the condition to be treated?
Mm-hmm. So this is a great question. The question is, a lot of times when we're doing research, we're trying to understand adverse events of drugs. And so can we disentangle this just from the vocabulary, or the CDM and the vocabulary in general? And I guess I'd pivot that a little bit and I'd say that's what a lot of the epidemiology research is for, is how do you set up the question appropriately? How do you set up a cohort? What timelines are you looking at? And what kind of analysis do you need to do to set that up? There are things in the vocabulary. The vocabulary will tell you what indications it is for. So it will, for warfarin, it will tell you what it's indicated for using a vocabulary search. But then when you're working in the CDM, you would need to set up an analysis to see, do I believe that these are adverse events, or was this just indicated for? Does that answer your question?
Yeah, I'm kind of thinking, can we just use the CDM, like for example, maybe looking for the temporal relation, right? So the conditions that occurs after the drug exposure can be treated as adverse event.
Yeah. And that's what we're trying to do, is set the data up in a format to make this type of analysis as easy as possible. So the question is, can we look at and understand what a patient's progress is after a drug exposure in terms of conditions? And that's why we're trying to set up the data. Certain data formats in their raw format actually make that question very difficult. This format actually makes that question a little bit easier. And then there's specific analytic methods that you would apply to think about, how can I be confident that there's an association between this drug exposure and this outcome? But that's another course that I should not teach you. Okay, so I'm gonna keep moving. We can keep asking questions. Let's see what we're doing. Okay. So we talked about conditions, but next, I guess, exciting part of the CDM is where do you put the drug exposure? So we have our drug exposure table, and this is supposed to represent when we think or believe that a patient has actually ingested or come in contact with a drug. So this is not situations where we're not sure. We want to, like, so for example, if somebody has a prescription and went and filled a prescription. While we may not know if they physically actually took the medication, we feel fairly confident that if you went and picked up the medication, you're probably are interested in taking it because you probably had to pay for it. If you're in a hospital and a physician has billed for a procedure, you probably really got that drug because a physician's not going to bill for giving you a flu shot when he never did, because that would be fraud. In this table, it's very similar to all our other tables. We have our unique identifier, which is the drug exposure ID. We have our person ID. We translate whatever code came to a drug concept ID. So a lot of people in this room probably think about drugs in terms of NDC codes, but these can also be ICD-9 procedure codes like the flu vaccine, and there's lots of different ways that drugs can come across. We can have a start date. Sometimes if you're lucky, you have an end date for the drug. You can have the type, which will tell you a little bit about where it came from. So for example, you could pick drugs up at the pharmacy. A prescription could have been written. So there's a slight difference of I went and picked it up versus doctor told you to go get it. That's slightly different. You may never go and pick up the prescription. You may have a medication or just, like I said, a physician procedure. You can feel fairly confident about that. Okay, so in Lauren's case, she doesn't really talk about going and getting a prescription per se. She probably most likely got an over-the-counter, which depending on your data source, you may or may not actually have that information. But she talked about pain medication, so I just guessed maybe she was taking some acetaminophen. So Lauren's record, let's just pretend that she got prescribed this acetaminophen for the example's case. So here's Lauren, and she went and got this acetaminophen 50 milligram tablet with hydrocodone. So it's a combo drug. And that gets mapped to a drug concept ID. She had a start date, and we can actually calculate an end date because it was a prescription. So we know when she picked it up, and we know how many days it's for. So then we can just calculate when the end date should be. Sometimes, like I said, you're lucky and your data set will actually tell you an end date. So we also have a column for verbatim end date because sometimes these dates won't line up. Given your start date plus day supply may not actually add up to that end dates. And then from an analytic perspective, you can decide which one do you believe more for a given data set. We have our type ID that's going to tell us, again, a little bit about what kind of prescription it was. If the physician is allowing refills, that we have a way to capture that. If there's a quantity of pills, we have capture that day supply. In this case, this was represented by an 11-digit NDC code. And so that actually also has a concept ID in the vocabulary. And so I can take that NDC code and convert it into a concept ID. Yes.
So this is a combo drug, and when we were looking at the drugs before, we had a challenge when they were combo drugs. So do some of the combo drugs, are they standard concepts and then some aren't?
So the question is, before we were looking at an example where we had a combination product and we were having a little bit of a trouble getting it mapped to a code specifically. In that example, it was a little bit of a trick question in that it was an classification code. So it was a code that it was DEMA's ATC 5 classification code. So right now, those classification codes, those don't map down to individual ingredients. In this case, this NDC, all the NDCs that we know about have, they get mapped to a concept ID. And then additionally, if you wanted to then say, take that concept ID and know the ingredients, we can do our vocabulary exercises from this morning and they will go down to ingredient codes. But
No, that's right, it's true what you're saying.
Yay.
So all products, also the combination products, are in there. Okay, not just in the US, everywhere, or well, in reasonable markets. Okay, what's not what the ingredient level in the RX norm vocabulary that we implemented here. We don't have just ingredients combined, just ingredients, you know, aspirin, acetaminophen, okay? That combination as a theoretical concept isn't there. The reason for that is most of the use cases, 90% of the use cases, you are studying a compound or an ingredient per se, so when it is in the bloodstream. And when it's in the bloodstream, it doesn't matter whether you took 1 pill or you took 2 pills. It's not different. It's only if you're truly looking at the product level, and there are these combos, that you need the combinations, and they're all there. In fact, half of the drugs are combo drugs. Okay? It depends. Some of the Europeans have more combo drugs than the Americans, but that's about the number that you get. So don't think we can't do combo drugs. The combo drugs are there.
Yeah, and it always ends up being your source. Some sources only tell you ingredients, and so you don't even know the dose level that they're at. And so what you want to do in the drug exposure level is stay at the level that you've got. So you can't go, more descriptive, and you should not roll up at all. Okay, I'm going to move on to procedure occurrence. And so these are, this is aimed at capturing when there's something ordered by or carried out on a patient for diagnostic or therapeutic purposes. Again, same structure we've seen already. We get our standardized concept IDs. There'll be a date. So usually we've seen a lot of start and end dates. Procedures usually they happen on a date. They usually don't happen across multiple days. Again, type, telling you a little bit about where it comes from. There's a modifier concept ID, so people from the claims world will probably be familiar with this. So for example, if you're having a procedure done on your knee, a modifier might tell you what knee it was. So we've carried that across because that seems to be valuable for research, especially if you want to know about, left knee reconstruction surgery versus right knee. A quantity, so procedures can happen, somebody could get 2 sticks of something. Again, if there's a provider that we know are associated with this, again, they can be associated with a visit or not. And then we can capture that modifier source value if we want. The vocabularies in here, so when we've talked about drugs and we've talked about conditions, we've talked a lot about SNOMED today, and drugs we've talked a lot about RX norm. And so while there's a little bit of diversity in there, for the most part, when we're talking about those things, the codes underneath and standardized codes are pretty uniform. For procedures, though, it can be CPT-4s, HCPCS, ICD-9 procedure codes, ICD-10 procedure, LOINC, or SNOMED. And this really comes down to, and Christian, you can correct me if I misspeak here, there's not a SNOMED for procedures. There's not an RX norm for procedures. And so we've just felt that the best way to represent this is by allowing the common codes that are used to be standards within this vocabulary. This also does give us the opportunity that there's going to be overlap between CPT or HCPCS. So sometimes if you have a procedure code that isn't mapped to a standard and you need to map it to a standard, you may actually have to pick from 1 or 2. So it's a little bit messier in here, but again, there's not a good vocabulary in this case. Let's see. So Lauren had a couple procedures as well. So she had a pelvic exam, an ultrasound, and she had some surgery. So let's make up a record for her. Let's look at an ultrasound. So again, she had a CPT, and this CPT was an ultrasound abdominal real-time with image documentation complete. And then we can map that. Basically gets mapped to the same exact concept ID. And this, because it was a CPT, it's just the standard code is the CPT in this case. We don't have to actually get it anywhere. Same thing, we get a date, and we know that this was an outpatient detail first position. And it was associated with a visit in this case. Okay, measurements. So this is when we're getting records that have numerical or categorical values. So for example, like if I'm taking somebody's temperature, this has a numeric value. The measurement table gives us structure to try to store this and improve analytic use case on the measurement data. if anybody's ever done any analysis on measurement data, you'll know it's very messy and very painful. And I will say that this table does not fix the fact that the data is coming across a mess. And usually I actually recommend that it's a mess that you probably should disentangle during analysis time. There is some work that the ETL can do to clean it up. So for example, if you have a diversity of units that come across in your measurement, you could try to clean that up on the CDM build. But a lot of times you're still stuck with a little bit of a mess when you're doing the analysis. So this table, same stuff, person ID, measurement concept ID, it happens on a date. The type will tell us where it came from. Operator concept type, that will be, it's like a plus or negative, right, Christian, before I misspeak? Like operator concept ID. So like sometimes a measurement lab will just say plus, or larger than, greater than. So if you get that kind of unit across, we're gonna represent that in a standard way. If you get a value as number, there's a field that's supposed to just store numeric numbers. You can also represent, if you get a value that's like high or low, we can take those values and then store them as standard terminology. So for your ETL builders, a lot of times this is a lot of work because different lab measurements will come across in lots of different ways. So high might be represented as H or high misspelled. And so sometimes the ETL builders have to go through and try to fix some of that. Again, we put all the original data in there so you can kind of disentangle if it didn't get it right. Unit concept ID, we try to standardize units and then give them concept IDs. It makes it a little bit easier. Again, if you've used data, you'll know sometimes they'll come all caps. Sometimes they'll come and be misspelled or not have the, or missing some part of it. So during the ETL build, you can try to clean that up. If your data tells you what the low and high range is for the instruments, that will come across as well. Who the provider was, if it was associated with a visit. And so, but again, this usually ends up being a little bit messy. Oh, I only had one example for Lauren. She mentioned she had a high temperature, so we can imagine that she had a temperature of 103 in the hospital and some physician or nurse made a record of that during her visit. So we can store this in the measurement table. We could say it got coded with a LOINC code, that there was a test about looking at body temperature, made a note of it. The units were degrees Fahrenheit, it had a date, tell you where it came from. There was some kind of physical examination while she was in the hospital. And then we can standardize that to a concept. So then if we want to go find body temperatures, we can look with it with a standard concept. Okay, observation table. This table is actually very similar to the measurement table. And actually, this used to be the place that we put all of our measurement data. But in an attempt to standardize the measurement data a little bit further, we've since split measurement data and observation data. Observation data really ends up being anything else. So shouldn't be drugs, it shouldn't be conditions, it shouldn't be procedures, it shouldn't be measurements. This ends up being the dumping ground for a lot of things where there's just nowhere else to put it, or it just doesn't fit somewhere else. So this can end up being just like clinical facts about a patient, survey data about a patient where you don't know where to put it, maybe medical history or family history. And so the structure, being similar to the measurement table, gives you a lot of opportunity to store that data. So for example, if you get, if it's a survey data, a patient gave some type of textual response, this would be a great place to just store that information, especially if it's not easy to standardize in any way. That way you still have it. You might not be able to use it for a simple analytic use case of doing patient level prediction, but you still have the information somewhere. So sometimes people call this the garbage can. This is where we can stick everything else. So in Lauren's example, she talked about missing work, and she we know that she had an ambulance ride. And there's really not other good places to put this information. And let's say I care about it and I want to bring it across. This would be the observation table would be a great place to store it. So in this case, this is a good example. And so here, Lauren, she had some type of record in the raw data that said work hours missed, and then it said the value of she missed 8 hours of work. But there's no good vocabulary for this. It's not really easy to standardize this. So both in the observation concept ID and the observation source concept ID, I've set them to 0. And 0 means I don't know. This is an unknown thing to me. So I'm still able to bring the data across and store it in my CDM. I'm just not going to standardize it in this case. As an ETL builder, a great thing about this is I can then, every time I do a CDM build, start to see what are the things I'm not mapping? Can I do a better job? Can I think about a way to get this to map appropriately? And then in my ETL, I can think about, oh, well, work hours missed, maybe there's a better way to do this, or maybe there is a concept ID that I'm not thinking about right now. Okay, does anybody want to ask any questions before I'm at time? Oh, okay. Okay, yeah, well, let's take a break.
Before we go, I think, Raj, you had a question? No. You keep raising your hand. Keep seeing in the back end, goodness. Power. Everybody good? Because they supposedly fixed it. But I need to go and say.
Does everybody have power?
Okay, so we're going to break for 15 minutes.
Okay. So we spent the last hour or so talking about what I would consider the more popular tables in the clinical data section of the CDM. But I really would like to also show you one of the derived element tables. I think it makes it a lot clearer about what's going on in these tables and the value that they provide. So there are 3 tables that people want to know about: the condition era table, the drug era table, and the dose era table. I'm going to talk about the drug era table because I actually think this is one of those tables. I think this is the more important one and is used very often in research to understand what people are being exposed to and the duration of that. So once you've built a CDM, and you get to the point where you've moved all your patient records into the CDM, you can then do a process to create a drug era table. And actually, once you have your data in the CDM, you don't have to figure this part out. The code's written. So there's a standardized approach to take drug exposure records. So those are those individual little prescriptions that you pick up or individual exposures. And what we're going to do is we're going to actually roll up those exposures to ingredients and then try to calculate the duration of exposure. So for example, if you're prescribed warfarin, you might be on warfarin for a while, and you might have, let's say, 10 prescriptions over a period of a year. What the drug era table is going to say is, for a given person, look at all the individual exposures, say what's the ingredients of these exposures, and then stitch them together as long as they're within a certain amount of time from each other. And for research, a lot of times what we want to know is we might not care exactly what prescription a patient was provided. What we care about is that a patient was exposed to an individual ingredient like warfarin, and we'd like to know when that started and when that ended. And like I said, we have the code to already create this. You would just process this once you have your data within the OMOP Common Data Model. So let's use Lauren as our example. So she talked about having exposures to acetaminophen or some kind of pain medication. So let's pretend she's on this pain medication, this combination product of acetaminophen and hydrocodone. So the drug era, the data in drug era is only at the ingredient level. So what that means is that given that Lauren has she has 2 exposures to the actual drug. So she has this acetaminophen hydrocodone. She has 1 exposure and then a second exposure. So she went and picked up 2 separate scripts. But when I convert that to my drug era table, it's actually going to end up looking at each individual ingredient from that drug exposure. So there's going to be an acetaminophen and reviewing what is the duration of exposure for acetaminophen, and then we're going to also review the duration of exposure for hydrocodone. So in this example, we have this combination drug that she's exposed to, and she picked up a script on February 1st and finished on the 8th. Then she came back 2 days later and picked up a script on the 10th, and she should have been done on the 17th. And so in the error table logic, even though Lauren had a little bit of a break in there, we believe that exposure, when we're building a standardized drug error table, we believe that exposures that happen within 30 days of each other, you're actually just continuously exposed during that time. Now, yes, given use cases might have different things depending on like the half-life of the drug, but from a standardized approach, we just build the standardized table of saying, if I see my exposures within a certain time period, I'm gonna just look at that duration. But then, again, because this is a combination product, I'm going to split it out into acetaminophen and hydrocodone. And in this case, I'm going to have two records, one for acetaminophen that starts on the 1st and ends on the 17th. So then if I'm interested, I don't care that she had 2 prescriptions of acetaminophen, although actually the drug error table will tell you how many prescriptions created that error. All I care is that she was exposed during this time, and I can use that in an analysis. So the drug error table ends up being pretty important in a lot of research that's done. We do a similar type of work for the condition table, and we do some high-level dose error building, but I would say the drug error table is a little bit more informative. I know this isn't a very easy concept to grasp, so I'm actually going to try to walk through a couple cases, hopefully to make this a little bit clearer. So on the left, there is a list of, think of these as exposures. So a patient went to a pharmacy and picked up 1, 2, 3, 4, 5 exposures. And then these exposures are going to happen over time. And in this case, it's this drug lisinopril, but that doesn't necessarily matter. So let's say this person went and has an exposure to this in NDC. It was lisinopril 5 milligram oral tablet. So in my CDM, I would have put that into the drug exposure table with a concept that told me it was lisinopril 5 milligram tablet. And then that person came back sometime after the prescription ended and picked up another script for the same drug for 30 days. But then something happened. Again, this is a claims world. Something happened. Maybe they didn't have the money to pay for it, so it kind of got reversed out of the system. But they ended up getting the drug somehow. So from a records perspective, I might see that like the drug came, it went away, and it came back again. So when we're thinking about building errors, this is one of the things we have to think about. How do we think about these reversals? In this case, the reversal end up just coming back anyway, so it kind of null and voided itself. But if you had the situation like this, you might not want to build that into your drug errors, or you might want to. It's just part of what you want to think about when you're thinking about patient time. Then you see we had our lisinopril 5 milligram. Then there's another NDC, and this, I guess this is like a branded drug or branded version of the drug. I'm not actually really sure. Zestril. Is Christian here? No? Huh? Okay, yes, it's the brand. So it's the same drug, but from a drug exposure record, it actually had a little bit more detail than the other drug. The other drug was just saying, I was exposed to lisinopril. In this case, it's saying, no, I was exposed to a specific version of the lisinopril. Again, on the drug exposure table, we want all that detail. And then this time, they actually got a 60-day prescription, so a little bit longer. And like I said, this was an NDC change, so if you were trying to understand exposure for this patient by yourself in the drug exposure table, you have a lot of work to do because the patient might switch across drugs. The patient might switch from 5 milligrams to 10 milligrams. The patient might have overlapping claims. In this case, they went from a 5 milligram dose to a 10 milligram dose to a 20 milligram dose. There can be blocks of time where the patient's just maybe not exposed to the drug. For example, greater than a 30-day gap. And in the drug error table, what we're trying to do is take away the work of the analyst having to stitch this all together just to figure out how long was a person exposed to lisinopril. And again, this is just a standard analytic case that we recognize is common in epidemiology, and so we just pre-calculate these tables. And also, like I said, depending on your drug, the 30-day gap may not be appropriate for what you're doing, but you can use the error logic that's out there and available to the community and just tweak it to the way that you might need it for your specific analysis. So for example, we might do analysis on some injectable drugs which would have a different way we need to think about it. So for example, often injectable drugs come across with 0 days supply, but you might be exposed to the drug for 30 days or 60 days or 90 days. In that case, this default drug error structure doesn't help me, but I can use the same logic to build up the same type of analysis. So I've covered a lot of tables today. I think the more popular tables, there are a lot more tables we're not going to talk about today, but there is, Claire is actually going to get a little bit into this, but Claire does a wonderful job maintaining information about the CDM. So even though we haven't gone over it, there are places to learn more about it. And with that, I will hand it over to her, you're just going to talk in this mic. I know, I would have felt bad.
All right, so I just have a couple little notes on some different places you can go to not only get more information, but try to maybe request some changes for things that don't particularly work for your data. So one of the questions we get a lot of times is what standards do I follow to ETL my data into the common data model? And how do I know that other people around the world are following the same standards that I'm following? So for example, if a patient doesn't have a gender, do we keep them? Do we not keep them? What if they have a biological sex and they identify as a different gender? What do we do with those people? So what we have is the Themis work group. And what these folks do is they get together and they discuss these questions. And we've had a lot of questions that have come up over the years about, we just had one recently about what do we do with DRG codes? That's a great question, and I think the Themis group is going to talk about it in the coming weeks. So over this last year, they've actually put together, I forget how many, but I think like 20 different conventions on top of some of the conventions that already exist in the Achilles tool, if you've seen that. And those with the release of version 6 have all now been added into our Common Data Model wiki, which you can see down here. So there's the wiki that shows you the Themis rules, and then if you want to get involved in the conversation about the Themis rules, there's also a work group as well as a GitHub devoted to that as well. And then we also, as we've been talking today about the CDM, we do have version control. So we try to really be aware of what's going on in the community, what people are needing, what their use cases are, and we try to grow and change with those use cases. So as Erica mentioned, we have a work group that meets once a month to discuss these proposed changes, and we try to be very open and listen. We have a voting process. It's a whole deal. It's not just like, let's throw new stuff in there. There's a lot of things that go into it, and you can see all the documentations, all the prior versions, proposals, everything out on our GitHub. And then if you want to get involved, all that information is out there as well. And we really welcome any input you guys have. We want to be as inclusive as we can be so that everyone can take advantage of all the wonderful tools and things that Odyssey has to offer. And just a quick note in version 6, if you haven't seen it yet, we didn't include the new survey table. We're moving more towards date times. We also have a results schema, which is like a big deal for this this one now. So if you are interested, go ahead and take a look out on the GitHub. We're really excited about it. Any questions? The result schema is used in Achilles, and it is more often used in Atlas. So if you've seen Atlas at all and you're going to be generating a cohort, that cohort table that used to exist in the CDM is now going to be in the results schema. And the reason for that is what we can do then is we can lock down the CDM tables so that they are read-only, so you don't have users possibly poking into your CDM tables, and you can have this results schema that is a writable table, so you can kind of keep those separate, which we've needed up until now. Any other questions? All right, cool. Thank you. That's all I had. Oh, thank you.
And no, you guys aren't getting another 15-minute break. Okay, so we spent a lot of time talking about the OMOP vocabulary as well as the OMOP CDM, right? So what the next section is going to show you is some examples so you guys can follow along as well as be able to play with the little box that you guys have with some of the examples that we're going to go through, okay? But before, so what you see here, Erica kind of talked through with you guys the scenario, and she kind of showed you guys how the tables are. Well, I'm going to show you more of real life. These are some of the scenarios that we've run into and some of the tables that we've had to deal with. What you see on the screen here are actually 4 different data assets, anywhere between claims and EMRs in both the United States and in Germany. And as you can tell, the file formats are very different, right? And it's just very typical. Even when you're in the same organization, your file formats aren't going to be the same. Okay, and then the other thing that you'll notice is these two, we're using ICD-9 codes. But these two down here, we're using ICD-10 codes. This one doesn't have a dot, that one doesn't have a dot, that one has a dot, that one doesn't have a dot. So when you come to doing analysis, it becomes very difficult for people to actually have to remember all the rules that I just talked about, which fields to go to, add them, subtract them. This one, it's not even in the actual record. You have to go to another reference table to get to the information. So it becomes very cumbersome in order to get what you want. So one of the main reasons why we think OMOP is awesome is once somebody does all this work for you, the analyst, it's very simple, right? But what we want to stress is the work that actually goes in to do this is not so simple. So, but how do you do it, right? So the first thing you have to do is if we take one of the data assets, well, you're going to have to standardize it, right? So the first thing that we do is we pull in their start date, and we tell you this is the condition source value. Erica kind of talked about that. We always keep the source value 1. Why? For quality assurance purposes, right? For people who actually do the conversion, we want to make sure we're bringing in the right thing and we retain the same thing. But also for the researchers, because they don't trust us IT people. They don't. They're like, you're losing my data, I lose a lot of codes, come on, prove it to me. So this way we can prove it to them. Look, we're retaining your stuff. Number 3, they really don't like using the new codes. They're so used to it. I'm like, I want my ICD-9 code. I want my ICD-10 code, right? Again, it's there. We didn't drop it. It's still there for you to see. And then Erica also talked about, you know, the condition concept, type concept ID, right? Where did it come from? Well, this happens to be the primary position, because this is an indicator of 1. Now, how do I know that? Because I know this data asset very well. But these are some of the things that you're going to have to work with your business people to figure out. Which type is it? Well, I also know, but we didn't show it here, is this is also an admitting diagnosis. So the type here would be inpatient claim admitting diagnosis as well. So you may end up creating 2 records. Okay? Then the other thing we would do is the whole exercise that Christian went through this morning of mapping it, right? Because this is the source. This is the original. It's an ICD-9 code. Well, remember, in OMOP, we use the standard codes. So then you have go through the mapping exercise to get their standard code and populate the condition concept ID, what the standard code is, okay? And then we do that same exercise for all 4 of these. So again, we tell you what the source value is, what the type is, and then we add in what the condition concept ID is, okay? By doing this, now if you query all 4 databases, it's easy, where concept code equals this guy. And you don't, or concept ID, I apologize. Then you don't have to remember all the other codes that we just talked about, right? Now, I heard earlier in the morning, why do we keep the source concept ID? Why do we need to store a source concept ID? Well, a good reason for that is this scenario here. Because if you just stored the source code, one has a dot, one doesn't have a dot. You have to remember all that. Well, here you don't. You just have to remember that the source concept ID is this, and it will go it'll grab both of these records and not have to, again, rely on this. So one of the big things I hope is a takeaway for you guys is OMOP is trying to make it easier for people to do analysis and to be able to get their jobs done without having to worry about how dirty the data is. That's another team's job. Hopefully you're not in that team. Okay? I am, but hopefully you guys aren't. So the data that you guys have been playing with is called SynPuff data. It does come from CMS, but we syntheticated it so that it can be used by the public and all of you guys can use it. One question that I've been getting a lot of is, this is great, we got an OMOP CDM model, so does the data behind it come with it? No. Sorry. Data always belongs to whoever the organization is. There is a process that you have to go through. The model itself is just a model. Okay, it's an empty shell after that. Someone actually has to do the ETL conversion and actually put the data into it. That's why we have a SynPuff series out there, so you can see what the work that we've done and be able to play with it without us having, or anyone having to charge you an arm and a leg for it. Okay? In the original data, there is 5 different files. These are the 5. You have the beneficiary, the inpatient claims, the outpatient claims, the carrier claims, and the drugs. So all 3 of these are different type of claims versus these are the prescription. So an Odyssey team went through and did the ETL job for what you see now and actually mapped these guys over to the model. And then publish that into the public. So the SynPuff data is at the CDM converted version of the SynPuff data is actually available out there on the Odyssey website. So if you want to download that and play with it yourself, you can, because the box that you have actually will be shut down tonight. If I remember to send an email. If I don't remember to send an email, it might be up tomorrow morning. Okay? We won't go through the little box. Now, we've been asking you guys to go in the box and type SQL, select star, blah, 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 blah. Half of you guys are like, oh my God, I don't even know what SQL is, right? And we showed you Atlas as well. Well, the exercises after this will require you to actually build a cohort in SQL. So we're really going to challenge your SQL skills. And this is like not a beginning SQL class. This is really an intermediate SQL class. Not. We actually have a cheat sheet for you. Some of you guys have already discovered the cheat sheet. Okay, if you can, in your box, go to this file, open, and then go to files. Because if you don't, you're not going to be able to do the next hour worth of exercises. Because it'll take you an hour at least to write one of them. Okay, and when that pops up, you will go to your desktop. Some of you guys have clicked on these accidentally earlier. You want to find the one that says, oh, darn, I changed the name of it. But it says OMOP CDM Vocabulary Training, I think 2018. Don't click on the extra, click on the other one. Can you guys find it? Yeah? It's on your desktop. It's inside your little box. You have to be in the little box. It's not on your actual desktop, on the little box desktop. Okay, we good? Can you guys find it? Open it. So then everything you've learned today, they're all sitting in that file. So if you want to have everything that's in there, maybe you can copy and paste that onto your desktop. Your real desktop, not the... So everything is there. If you scroll down to exercise 0, that's where we're going to start our exercises in. All these are from the morning. Again, we were trying to make you guys work a little harder in the morning. In the afternoon, I know it gets sleepy, so we're trying to give you guys a break. Okay, so the exercises we're going to go through today, we have 4. One is just finding warfarin. Right? Based on the study that Christian talked about this morning, the Graham study that we're trying to replicate, right? It's comparing people who were first-time users of warfarin compared to dabigatran folks who had previous atrial fibrillation, and which one caused more bleeding, right? So as part of our exercise, we're going to first of all go find, just find warfarin. How do you find warfarin in the system? And then how do you find new users of warfarin in the system? And then new users of warfarin who are over 65, and then new users of warfarin with prior atrial fibrillation. So those are the 4 kind of different cohorts that we're going to go through with you guys. The first thing is warfarin, of course, is a blood thinner that prevents blood clot. Where do you think in the CDM we're going to find this guy? Where do you think in the CDM we're going to go find warfarin? This is to see if you guys were paying attention to Erica. Okay, they were paying attention to Erica. Drug exposure. Okay, so there are, once the data is transformed over, again, we're going to have to use the standard code. When we do OMOP queries and OMOP exercises, we always try to tell you to use the OMOP standard codes. Don't go back to your native codes. I know it's very, 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 very tempting to go use it. But that's why we have tools like Athena to go help you figure out what the MAPS to is, and then you can get used to that. Okay, please do. So that's why, again, we don't really care about the raw data. So please try to use what the standard code is, because there are going to be times that you might have missed something, and you won't realize it, because they add NDC numbers all the time, and you have to constantly keep track of it. It becomes a pain in the behind. Right? So typing in metformin or typing in something like dabigatran is going to be a lot easier, and hitting a little descendant button is going to be a lot easier than maintaining a full list of NDC numbers. Okay? So how do I define warfarin? Well, there's 2 different ways. One is the SQL way, and then the other is the Atlas tool. For the purpose of this class, we are trying to teach you guys conceptually what it means to go find something, and conceptually how to use this OMOP model. So the class is actually basically SQL, but we're not asking you guys to learn how to write SQL. That's why we're giving you the exercises and giving you the code. But we're going to walk you through the SQL. But at the end, we're also going to show you what the Atlas tool looks like. Okay? And so that next year, if you guys want to, go take the class next door, or actually go watch the class next door when it comes online. Okay, so the first thing we're going to do is, if you do this, we're looking for the ingredient concept, right? So select my distinct list of patients from the drug exposure table where drug concept ID equals warfarin. Anybody want to take a guess on how many patients I'm going to find? Looking for the ingredient of warfarin. There's really only one answer. Doesn't matter how big the data is. I'm sorry. 0. Did you cheat? Are you looking at the deck beforehand? Is that what it is? Why is it 0?
Because there's ingredients of warfarin. Is that right?
Because you're looking at the ingredient level, yes. You're not looking at all of its descendants, right? Again, in your data, most of your data assets aren't ever at when your transaction levels, they're not really always at the ingredient level. 90% of them are always at a level below that, or even a level below that. They're typically your product, your form, your strength, right? Maybe sometimes at your product and your form, but maybe sometimes at your product, form, strength, or your box size if you're from the European world, plus your manufacturer or any other granular level. Here, I'm literally just saying equals, so this is just looking for transactions that literally have just warfarin in them. Now, in some databases, you would have some because sometimes they do that. But in this particular SIMPUF data asset, purposely, there are none. Okay? So the next one, if we do this, so I'm looking for, this is the right way to do it. Okay? So you're going to go select the count of patients where drug exposure, and then where the drug concept ID is all the descendants of this ancestor. Okay? Because again, we want all the descendants because it doesn't matter. You don't want to go through Germany's ephemera ATC and figure out all the codes when you're trying to compare a German study to a German population to a US population, because you're going to pull your hair out, because we did it for 6 months. So I don't think you want to do that. So that's why, again, you always want to do this whole descendant where the concept ancestor is the ancestor that you're looking for, and then you will get a lot more results, okay? And you should get this, all of these exercises, sorry, before I keep going, is using the 2.3 million SIMPUF data asset. So if you're on the smaller data asset, your numbers will be a lot smaller than mine. Okay, so when you guys do the exercise, please make sure you're in the 2.3 million data asset and not the little one, okay? And then what they showed earlier is you can do it by drug class as well. So if you do have an ATC drug class, you can do the same thing. And the query is pretty much exactly identical to this one above, except this here I'm looking for the ingredient, which is the standard RX norm code for warfarin. Here I'm looking at an ATC class higher up, right? And again, you should be able to do that and run it and get people. And you'll notice I do have more people, which makes sense because this exceeds just warfarin. This is anything else that's in that same class. Okay, so again, this shows you how powerful OMOP can be and the vocabulary that's already been built in, because you don't have to remember all this stuff. You just have to do, okay, I want that class, and give me everybody underneath there. Questions so far? Okay. So if you want to find new users of warfarin, how do you do that? Well, first we have to define what's a new user of warfarin. Right? Everybody has their own definition of a new user of warfarin. And everybody's going to argue that my way is better than the other person. That's just how it is. So, but in typical cases, a definition is someone who was recently taking warfarin and typically having a 6 or 12-month washout period. Or some people call it clean period. Some people call it look-back period. Terminology-wise, they could be called anything. But it's just a period before that drug exposure that you took that you've never taken that same drug. So that's really what a washout period means in this book. And whether it's 6 or 12, really a lot of times it depends on your analytic period, right? Most people 1 year to 2 year, they typically take 6 months. Some people like to take 12 months by the time they get to 3 year. Some people, I don't think we normally do studies above that, but sometimes you can. So all that is really based on your methodologies that you guys have in-house. In our case, we're just going to use 6 months for the sake of argument. We're just going to use 6 months. So if a patient, Puchin over here, very unhappy Puchin over here, because she, it's a she, right? She is sick, and but she has records here. She has drug records. We were able to find that she has these warfarin drug records between 2011 all the way to early 2014. Okay. This one, if I look at this record, and if I were looking at this this particular date here, this person would not, this record wouldn't fall as a first-time user, because again, I have a transaction right before that in that same year, right? Not 6 months before yet. So this particular record would not equal a new user of warfarin, okay? But if I looked at this one and the fact that this person was observed in the data from 2009 all the way to 2014, then this person would qualify. And this goes back to what Erica said earlier about why we always use observation period. It's very important because it tells you when I was observed, because for criteria like this, if I don't know when they were observed, then I can't consider them a first-time user of warfarin, because if they weren't observed in my data, what guarantees me that they didn't just go buy warfarin off the shelf, or that they got it from another payer, or they got it from another pharmacy? So there is no guarantee, and when it comes to medical research, we try not to do we try to make sure it's a guarantee of an accuracy. Right? So therefore, observation period is very important in some of our studies. Now, if this user cut off right here, right around here, then they wouldn't be a first-time user of warfarin again, because their observation period doesn't meet that 6 or 12-month criteria. Okay? Now, that first index, this little drug here, is what we call the index drug. Okay? It's the one I anchor on. So therefore, it's called the index date. Okay? So that one is my index date, and I'm going to go 6 months ahead is my timeline. Okay? So these are the 3 tables that we're going to use, because the OMOP is being used to find the vocabulary. The drug is where all the drug transactions are. And then the observation period is to figure out when they were observed in the database. Okay? This is what the sequel looks like. So if I break this down step by step, you have here, which we talked about earlier, I'm finding all my descendants of warfarin. And then I'm taking the unique people, and I'm getting the minimum drug exposure date, because I'm looking for the first one. Okay? Find me the first one and set it as my index date. So what we talked about earlier, I'm indexing on it. So I'm anchoring down on that guy. Okay? And then I'm joining it to the observation period to find that the person equals the person, and that the index date is between the observation start and end date, because I want to make sure that index date is being observed to begin with, right? And the fact that the difference between the dates of the index date and the observation date is greater than 180. Okay, so that's kind of how the code reads. Again, I can have you guys write this, but it'll take you an hour. So again, this is what it would be. So I would like you guys to try this on your own, run it. Shouldn't take you guys that long to run it, besides to hit the little button and actually hit the button, and watch it slowly spin on your desktops and see how fast our internet is. Raise your hand if you have questions, okay? Hopefully there shouldn't be any, but you never know. So the question is, what are the common ways to populate the observation period, right? Let's see. I can only tell you from my experience what the common ways to populating the observation period is. So claims-wise, right, you typically have some kind of enrollment information. So for claims, it's pretty straightforward. You would say it's the start of their enrollment to the end of their enrollment, right? For many hospitals or many ambulatory settings, you don't have payer information. And if you do, you don't know when their enrollment period is. So therefore, the most common way to do that is the start of their first transaction to the end of their last transaction. Okay, and then there are some, like CPRD and UK, we have one called THIN. They have business rules in there that, that golden standard, right? CPRD has that golden standard. I have a different one that says based on a certain standard as well. And then you would use those business rules to figure out what their observation start period and observation end period is. Before last year, when we started this whole observation period, and with CPRD and UK THIN, we had a rule in there that says you can't have data outside of the observation period, because that makes no sense, right? You're not being observed. But with CPRD's golden standard and the database that we have at IQVIA, we changed the rule. So Themis changed the rule to say that you can have data outside, transactions outside the observation period. But that makes the observation period even more important, because the observation period is basically now telling you that that is exactly when the person was being observed. Anything outside of that, I'm not guaranteeing is accurate. But at least you still capture that data. So that's actually one of the things with Themis. That if you guys bring those use cases to us, we will actually evaluate it with everybody else and understand all the different use cases and potentially change the rules.
And it depends, I think, on the source of the data. So sometimes when you have a data source which is dependent on providers, like
Mm-hmm.
a group of hospitals or a group of providers providing the data. So you can use that in your observation period because maybe a hospital XYZ provides data only for this year, but not for
Correct,
years.
correct.
So you don't track individuals, but you track providers and build some business rules around that. So we've done that.
Yeah, so you're right. So I mean, like you said, your scenarios, you kind of know because that provider only provides you data during that particular period. So then in your case, that would be your observation period.
Or you build in like looking at whether providers has activity.
Activity, correct. Yeah, so all that logic, I mean, so again, building ETL, there's a lot of commonality, but I can tell you no two data asset is ever the same. So, but we do have commonality, and that's the purpose of Themis. Themis is trying to help bridge that gap because there's a CDM model that says, here's a wonderful model. But how do you then translate all that? So we have a lot of these scenarios, and we have a lot of these questions that gets brought up. So we're trying to, in Themis, come up with a standardization, put in some examples in there, and publish that documentation out. So we really urge everybody in this room to join Themis. If you want anything to know about Themis, come to our poster tomorrow. We have a poster about Themis and where we are and where we're moving towards. And we would love all the scenarios that you guys are talking about because like yours, I don't think we've run into it yet. And no one's actually told us that either. So again, we could put that as an example in the documentation to say, here's what it is. So, has anyone's come back? Yeah. Oh, yay. Do we have an answer? What was it? Run it, and how many patients do you have? How many distinct patients do you have? 361,007. Hopefully everybody got the same answer. And yeah, nobody's going to scream out like 08, right? Okay. So how do you find that? Because some people are like, what are you asking me for? It's not this, because you might have to scroll a long time to get that answer. It's right here. You know, or you can change my select statement to go give me a count, but again, that might take you a while. But it's right there. It's this little number that's over here that tells you. Okay? You had a question? No. You're like stretching. Okay, got it. Okay, so what we're going to do next is to go find new user of warfarins who are over 65. Anyone want to take a wild guess of what table we're going to add into this query? Wow, person. You guys have been paying attention to Erica in this class. We like that. So same thing. Watch out for Puchin. Poor little Puchin. He's changed, gotten really old. With the little hat, with the mustache. Okay, so we are adding in the person table. Okay? And the query looks pretty much the same, right? We still have all this information here, same thing. All we're really doing is doing a join here to the person table where we're looking at the year of birth is minus the index date is greater than 65 because that's all we're looking for is the fact that they're over 65, right? So it really didn't change the query all that much besides doing a join down here, okay? So how many people do you get? I'm not going to make you guys sit here and twiddle your thumbs and run this. But you should get a little less than the original one because you expect some people to drop off because some people are young. Okay, these guys might be a little older, but we do have younger population in this data. Okay, so the last exercise we're going to do here is this one. So again, we're trying to find new users of warfarin with prior atrial fibrillation. So again, we have our index date, we have our 6-month washout period, and in this case, I'm just looking for prior. I'm not saying that they have to be within the 6-month period. Just as long as they're prior, then we're good, okay? So, gave the answer away there. Which table do you think we're gonna go to next? Atrial fibrillation. Where do you think atrial fibrillation is gonna sit in? I hear some people going, we're going to add condition occurrence to the tables. Okay, so similar, this is what we had before. Now we're going to, again, we want to stress that we always want to go and get the descendants. because just atrial fibrillation is just one thing. But if you remember seeing in Christian's slide, there's a lot of layers underneath atrial fibrillation. And your data may be stored at that level, or your data might be stored at the higher level. So you really don't know. And again, for OMOP, it doesn't matter, because as long as you grab all its children, then you get everything, regardless if the data is at the lower level or at the level that you're looking at, right? So again, we always want you to grab the descendants. And then you are joining on the person. And you also want to make sure that the condition start date for this particular atrial fibrillation is within the observation period. Because again, if they're outside, then there is no guarantee that they were diagnosed incorrectly. Okay? And the other thing that we want to do is that we want to make sure the condition start date is less than the index date, because I'm just looking for prior. Doesn't matter how much prior, I'm just looking for prior. It could be, I don't know, 10 years prior, 5 years prior. It could be the day before, okay? And that's what we want to do, so therefore that's what this looks like. And that's the query itself. Now, I'd like for you guys to try this on your own and watch the little guy spin again. We should have a contest of who gets to get it to come back the fastest. So while it is running, one of the things I do want to show you guys is Atlas, right? I'm buying myself some time because of all this silence is driving me nuts. So you guys can click. So leave your little box running, leave your little SQL running. But you'll see is there's a little Chrome icon on your desktop, okay? If you click on the little Chrome icon, it should open up to your Atlas home. So it should open up like this. This version of Atlas is a little outdated than the version that I showed you in the public domain earlier, because we haven't updated the box yet. But you can actually create the same thing that you just did by hitting the Run button in Atlas as well. And if your Google Chrome doesn't take you directly to the page, you can actually click on this little Atlas home button, and it'll open it up for you. And if it just keeps spinning, hit F5. Little tips, little tiny tips. Okay, so you can actually go and build your own cohort the way we just did it earlier. So here, if you click on cohort definition, you'll see that we already built one. But again, I'm trying to buy myself time and not watch that little clock spin. We're going to walk you guys through how to build a new cohort, or at least some parts of a new cohort. Okay, so you're going to hit the little new button. Again, each one of you have an individual box, so what you do won't impact the person next to you. So it's okay for you to go wild in your little box, because then I just shut them down afterwards, and they get all wiped out. So what happens in the box stays in the box. Okay, so here, make sure you give it a name. One thing with Atlas that, again, I have a lot of caveats, okay? This app, all these apps are built by wonderful people who wanted to make sure that you guys had something to play with instead of typing SQL, but they're not great UI people. So in Atlas, every cohort name has to be unique. So when you guys have your own Atlas and play with it, you can't just name it cohort 1 and thinking that cohort 1 is going to be okay. So you have to name it something unique across the whole system, not just across users, but across the whole system. Okay? Again, little caveats. So name it whatever you want to name it. And then what we were doing earlier, so we have in Cohort Builder, we have initial events, and then we have additional criteria, and then we have exit events. So the initial event is that index event that you're looking for. So what we talked about earlier, the one that you want to anchor on. In some studies, it may be 3 different events, right? So if you're looking for type 2 diabetes, maybe it is the diagnosis code of diabetes, or maybe it's the fact that somebody took metformin, or maybe it's the fact that their blood sugar was too high. So it could be one of the 3. It can't be all 3, but maybe it would be one of the 3. Okay, so in our case, what we were trying to find is new users of warfarin, right? So you would actually come over here in the initial event, and like you guys said, we're going to pick drug exposure. Okay. And you're going to come over here, and it says any drug. So right now, you got people having any of the following, right? So we're going to go and actually import a concept set. And you'll see that there is none. Well, because you haven't created one yet. So makes sense. Go click the new concept set button, right? So then it takes me to this page, and I'm like, where am I? What am I doing here? Oh, it's down here. You have to give it a name. See, warfarin. Okay. Let me know if I'm going too fast. Then you're like, okay, I created a name for it. Now what? Because there's no button in here that says, give me my list of concepts. Again, little tricks. You actually have to come over here on the left-hand side and hit the little vocabulary link. Tricky, huh? Now, what you'll notice, and it's very, you want to make sure, a very useful tip to remember, is up here, this breadcrumb. It says that I'm in my demo and I'm in warfarin, okay, in my concept set. Sometimes, if you don't remember that and you don't exit out of what you're doing, the app doesn't work. Or funky things will happen. So make sure you know where you are by looking at the breadcrumb up here. So now, we can go and find our warfarin. Oh, boy. Oh, boy, did I spell that right? Duh. How come you guys aren't telling me I'm spelling wrong today? Oh, it's too small. Oh, that would be a good thing to know. Let's make that bigger then. Now you can see. Oh, now it's huge. Okay, so same thing like Athena, on the left-hand side, I could do filtering, right? So I know I'm looking for a drug, I know I want the standard, and I know I want ingredient. Where are you? I'm telling you, this thing's not in alpha order. Oh my goodness, I found it. Okay. So, by default, don't click on the button. Don't click on the blue, please. Do not click on the blue, because that's what you want to do. Don't click on the blue, okay? You probably clicked on the blue. Yeah, don't click on the blue. Click on the little shopping cart that's grayed out. Very intuitive. Very, very intuitive, okay? We went to Amazon and learned this, okay? Click on the little shopping cart. Do not click on the blue. This is what you get for going ahead of me. Okay? Next time, don't go ahead of me. So when you're done, if you go back and click on the little shopping cart, you can click back to your demo at the breadcrumb at the top. Okay? And now what you'll see in your concept set is that we've added warfarin. Okay, but again, remember from the exercise 0, adding warfarin won't give me anybody, okay, because that's just the ingredient. So, of this row right here, what do you think I should go do? Descendants. Check that little checkbox. Boom, there we go. You notice that when it's not checked, this included concept says 1, right? When I checked it, it went to 553. So just like that, it included everything that's underneath warfarin. Now, one of the cool things about that is you can come here and actually look at the full list. So if you do have a list of warfarin, and then there are scenarios that people do this, because we have pharmaceutical people in here who says, this is 100% a definition of warfarin. I don't care what you tell me, this is my definition. Well, you can still do that. Here's the full list. Now go and uncheck the ones you don't want. It's a lot easier than building it yourself. Okay, so to do that, you would click the little shopping cart and then uncheck the ones you don't want. Okay, but we're not going to do that again. But just like that, I've included everything that I wanted. So here, if I go back to my definition, okay, earlier we talked about, again, continuous observation. I'm looking for people who had continuous observation of 6 months before that because I'm looking for that washout period, right? So I want them to be continuous observed for 180 days beforehand. You can type it in. I'm not going down and scrolling. But I don't care about whether or not they have observation period after because I'm just looking for that clean period beforehand. In our graphs, remember that we didn't talk about anything afterwards. And I want the earliest event because that was where we said find the minimum drug exposure, right? So you can do that. And by virtue of that, this was running the first cohort that we did. Little trick, again, hit the save button, or else you can't do anything else, okay? And then when you go over to generate, you'll notice both the SIMPUF 10K is in here, and also the SIMPUF 2.3 million is in here. Click a button and watch it run. Okay? That's kind of a very brief description of Atlas. So anybody get results back from their query that they executed?
Where was it generated?
In the SQL. Still running? Oh, jeez. Oh boy, how do I get out of my box? Oh, there it goes. Oh. Either I'm wrong or you're wrong. Probably I'm wrong. As a customer service people, I never say my clients are wrong, so I must be wrong. So, but you get the gist, right? Okay, anybody want to try the bonus one or anybody? So I give you guys 10 minutes, okay? Either one, you can try our bonus one using SQL, or you can go play with Atlas for 10 minutes in the little box you have and ask us any questions you want about the fact that it would be great if the tool would produce the SQL, so then I can take it to somebody else and walk away with it, right? Guess what? It does that. So what you guys didn't see, or I haven't explained, is when we're in here, so the cohort that you guys created, right? Oh boy. Oh, I'm in the wrong Atlas. This is the public Atlas. It would help if I'm in the right one. Okay. So this particular one we generated, I'm going to actually hit that for fun. What you'll see is there's an export tab. Oh, this version doesn't let me do anything while I'm in here. There we go. So there's, in the export tab, you'll see we have a text view of what you did. So it kind of explains it to you better than the little UI that you saw. But there's also a JSON where you can copy and paste it, as well as there's SQL. So here, all of our cohorts have a SQL render, and you can import it to any of the SQL databases that we've developed this for. So SQL Server, Oracle, Postgres, if you guys are Redshift people, if you guys are Impala people, the newer version has Netezza on it as well. And if you guys are sharing atlases with other people, like you have an atlas and I have an atlas, you really don't need to copy the SQL either. What you can do is grab the JSON and come down. Does this low version have it? Yes. Copy the clipboard. So I copied it, okay? So pretend that I'm in somebody else's cohort now. I'm in somebody else's atlas, right? I hit the new cohort. Go to the little export tab again. Ooh, my control A's don't work here. Oh, because it's not my laptop. Oh, now I screwed up. That's it. How many demos actually ever go perfect? Thank you, 0. Why is that? Because people get too nervous, right? Control A, Control C, go away, new, export, JSON, Control A, Control D, Control V. Okay, so I copied the whole JSON file over from my original one into this new one, hit the little reload button, and that entire cohort has now been loaded into my new cohort. Okay, so again, Odyssey is made not only for standardization, but so that everybody can collaborate a lot more easily and a lot more in a standard fashion. Okay, so we have some tools. Like I said, next year, go next door, learn that one, or watch the video. Yes, I have a question.
So on the issue of collaboration, the way I understand it is that you have your own data and the institution have their own data. And you could give them scripts to test on their data, but what if you wanted to combine, I mean, the data is different institutions.
Uh-huh. Uh-huh. So the question is on the level of collaboration, right? If you had a data asset and somebody else has a data asset, a different institution has a data asset, when we share these queries or share the JSON or whatever it is, they'll run one, you'll run one, you get some results, you'll say, I have 500 patients and you have 300 patients, right? How can I combine the two into one? Well, like you said, that would have to go through all your IRBs, go through all your PHI, to go through all your securities. There is a way to do it. We actually, internally, we have a project that allows you to do that, but it's commercial, sorry. Where you have to, we would send a algorithm in to identify your patients to see what your patients are, and then an algorithm goes into mine and see whether or not they're the same people. Right? And if they're the same people up here, right, then that key can go back down, and then you can see that you have duplicates. But that's outside of Odyssey and OMOP to begin with, right? It's no different if you were using any model or even its native data. That's outside of the model itself. But it's not that it's not possible, but it's outside the model itself. So, Rima? Yeah, it can be. So people can use, it could be the same ID, but it's a different patient. So again, but that's not even an OMOP problem. That's just outside of OMOP because it's just your data and your patient, how you created your patient IDs, right, in between the two institutions, and whether or not they're the same patient. So that regardless if I'm using my native data asset or if I put it on FHIR or I2B2 or Sentinel, it wouldn't matter. You're still going to have that problem. And that's something that is a process outside of OMOP. It's outside of Odyssey and outside of OMOP. So any other questions before we wrap my portion of it up? No? Well, thank you. I'm going to turn it over to Rima.